All right, 6.3, linear functions. Again, textbook reference page for you. All right, so a linear function is a function whose graph is a non-vertical straight line. A linear function can be written in the form y equals mx plus b. We already know that m is the slope and b is the y-intercept. So now why does it say it's a non-vertical line? Well, think about our vertical lines. Those can't be written as y equals mx plus b. Those were just x equals some number, okay? So they couldn't be written in y equals mx plus b. It's also not going to be a function because if we think about coordinate points on here. So for example, if I have 1, 2, 3, 4, 5, this is x equals 5. That means I have a bunch of different coordinate points. So let's name some of those coordinate points. So this would be the coordinate point 5, 0. This would be the coordinate point 5, 1. This would be the coordinate point 5, -1, and so forth. We already learned that a function shows that each input only goes to one output, but I've just shown you that the input of 5 goes to 3 different outputs. So we know it can't be a function. So this is still linear, it's just not a linear function. Every single other straight line that you can draw that's not straight up and down is going to be a function though. Okay, so use the graph to write a linear function that relates y to x. So we can think about this. If I had drawn in a straight line, if it's asked me to write a linear function, that's basically saying write the equation. That's the same thing. So we're using our new vocabulary words to describe something that we've already learned how to do. So we need two things to be able to write the equation. We've learned we need our slope and we need our y-intercept. So my slope, well, I can count between points. I can go up 1, 2, 3, and over 1, 2, which means my slope is 3 over 2. My y-intercept is where it crosses my y-axis, which you can see is down here at -3. So my equation would be y is equal to 3 over 2x minus 3. We put plus and -3, same thing. Okay, so now it says to use the table to write a linear function. So again, write a linear function means write the equation. Y equals mx plus b, that's what we're looking for. And it does say to start by plotting the points. Oh, my pen carried a lot on that one, I'm sorry. Okay, so let's go ahead and plot the points. So I have the point 3, 9, which would be right here. 2, 7. Oops, those are positives, not negatives. So I apologize. That should not be down there. Let me erase that. Okay, 3, 9 is up here. 2, 7 would be right here. 1, 5, and 0, 3. So I can plot my points. And then I can count my slope. So I'm going up 1, 2, and over 1. So I know I have y is equal, a slope of 2 over 1 is just 2. And my y-intercept I can see is right here at 3. So I was able to write my equation from the table. You also could have found it without graphing it. If it didn't say to plot the points, you could have started by just finding the slope here. So remember, you've got 2 coordinate points. This is one coordinate point. This is another coordinate point. It actually gave you 4, but you don't need all 4. And then we can label this as x1, and this would be x2. This would be y1 and y2. And then our formula for slope is y2 minus y1 over x2 minus x1. So my slope would be -2 over -1, which means my slope is a +2. My y-intercept is where it crosses the y-axis, which is always when you have the coordinate point 0, something. So this something is your y-intercept. So again, you can see my y-intercept's a 3, my slope is 2. I was able to find it algebraically as well as graphically. All right, so use the graph or table to write a linear function. So they've got 2 problems, one from the graph, one from the table. Go ahead and try both of these, pause the video, and then come back and check and see how you did. All right, so I can find my slope and I can find my y-intercept. So my slope, I'm going up 1 and over 2, and it's slanted in the negative directions. So that's a -1/2. Get rid of that line. Okay, my y-intercept, you can see, is down here at -1. So my equation would be y is equal to -1/2 x minus 1. For the next one, again, I can pick 2 points, so I can rewrite them if I want as 2, 2, and 1, 2 if I want. Label them as x1, y1, x2, y2. Find my slope. So it's y2 minus y1 over x2 minus x1, which gives me 0 over -1. 0 divided by anything is 0. Not undefined. That's if you're dividing by 0. You can do 0 divided by something. So my slope is 0. My y-intercept is here at 2. I can simplify that. 0x actually cancels out, so it's just y equals 2. If you think about it, it's going to be a horizontal line if I graphed it, y equals 2 like that. All right. So next up, we have a word problem. It says you are controlling an unmanned aerial vehicle for surveillance. The table to the right shows the height in thousands of feet of the vehicle X minutes after you start its descent from cruising altitude. So the questions is on the next page, so I'm going to scroll so you can see them, and then I'll go back up and show you. So it says, first of all, we're writing a linear function, and we want to interpret both the slope and the y-intercept. Okay, so we're writing a linear function, so that means we need to find the slope and the y-intercept. Well, I can see my y-intercept is right here, so I know my b is at 65, and then let's use 2 points. So this would be the point 0, 65, and this would be the point 10, 60, and we can find our slope. So my slope is equal to, let me label them for you really quick, my y2 minus my y1 over my x2 minus my x1. So my slope is -5 over 10, which simplifies to a -1/2. So my equation would be y is equal to -1/2, man, my pen is sorry, -1/2 x plus 65. So there's my equation. But then it says we need to interpret both our slope and our y-intercept. So let's start with our y-intercept. Our y-intercept says that we're at 65,000 feet after 0 minutes. Okay, so before we started surveilling it, we can find, or that's its starting height. So 65,000 is the starting height. And then my slope, so we think this is our y's over our x's, so it's going down 1,000 feet every 2 minutes. So my slope tells me the vehicle is going down 1,000 feet every 2 minutes. And we know it's going down because it's negative. It would be going up if it were positive. Okay, so that's part A. Part B then says it wants us to graph it, and then we want to find the height when you stop the descent after 1 hour. So let's think about what our graph would look like first. So a lot of you are going to start with it like this. I would actually say we could start with it looking more like this, because we know we're talking about when time is positive, we can't have negative time, so we don't have to worry about having anything over here. And we're talking about height over this way, and that would be in thousands of feet. Okay, so when we're doing this, we know we're not going to have negative height either. Okay, so let's see. We have to go up to 65. So we could go up by tens, for example. 10, 20, 30, 40, 50, 60, 70. As long as I label them, I can go up by whatever I want. And time, we have to go to 30. I'm going to also go by tens for this one. So 10, 20, 30, 40, 50, 60. I'm going to go all the way 60 because I know that that's the next question. I'll label them. Okay. And now we can plot our points. So at 0 minutes, we're at 65, which would be halfway between 60 and 70. At 10 minutes, we're at 60. At 20 minutes, we're at 55. At 30 minutes, we're at 50, and so forth. Okay, so we can take a look at our graph. We can extend it as well. And now it says, find the height after 1 hour. Well, after 1 hour is going to be 60 minutes. So that means I'm going to take my equation and I'm going to plug in a 60 right here. So it's going to be the equation y is equal to -1/2 times 60 plus 65. So y is equal to -1/2 of 60. Well, 1/2 of 60 is 30, so I'd make it a -30 plus 65, which when we do that math, gives me a positive 35. So find the height. Well, it'd be at 35,000 feet. Okay, it is a word problem, so you do want to answer it in context of the problem. So make sure you put that label on there, and make sure you notice that it does say it's in thousands of feet. So it's not just 35, it's 35,000 feet. All right, last one. It says to write a linear function. Manager A earns $15 per hour and receives a $50 bonus. So they get $50 one time. Let's write an equation for that. So this is for manager A. Y is equal to $15 per hour, that's my slope. And they get a one-time bonus, that's my y-intercept. Because you don't get that every hour, you get it one time. The graph over here shows the earnings of manager B. We could write an equation of this one if we wanted as well. So we've got coordinate points here and here. So let's find the slope between those 2 points. So I've got the point 0, 0. So if I do y2 minus y1 over x2 minus x1, I can see my slope is 75 over 3. And let's see, 75 over 3, if I were to do that division, does come out to give me 25. So I know my slope is 25 over 1, or just 25. So that means it's going to be y is equal to 25x. And technically I have a plus 0. I don't have to have that written, but I can because it had a y-intercept of 0. So which manager has the higher hourly wage? Well, now we've put them in a way that we can compare them. The hourly wage is our slope, how much they get per hour. So you can see that manager B has a higher hourly wage. So I should probably write manager B has a higher hourly wage. And then it says, after how many hours does manager B earn more money than manager A? Well, we can start by making a table for each of them. So we've got manager A and we've got manager B. And let's see, we can plug in when we have 1 hour, we can skip down to maybe 5 and let's see what happens. So at 1 hour for manager, and I should put this, hour should be its own column. 1 and 5. Let me clean that up a little bit for you. Okay. So after 1 hour, manager A would be 15 times 1 is 15 plus 50 would be 65. And manager B would be 25. Let's see what happens after 5 hours. I'm skipping around until I start to see a pattern, see what's happening. So after 5 hours for manager A, I would have to do 15 times 5, which is 75. And then I would add 50 to it, which is 125. And for B, I would have to do 25 times 5, which is 125. So I'm getting close to figuring it out. Let's see what happens after 6 hours. So after 6 hours, we would do 15 times 6, which is 90, plus 50, which is 140. And for the bottom one, for part B, I would do 25 times 6, which is 150. So after how many hours does manager B earn more money than manager A? Well, you can see anything more than 5 hours. So if you could only work a set number of hours, so whole number of hours, you could say 6 hours. Probably a better way to say it would be after 5 hours. So not at 5 hours, after 5 hours, manager B would be making more, because after anything after 5, we know that this number is going to be the higher one. All right, so linear functions. Take a second, write your summary. What are we doing with linear functions? Can you identify whether